Formula creation. I'm going to briefly go over the steps to that again. We have a pattern here with matchsticks. This is the one you did in the challenge yesterday. One of the things you could do is to try and draw the next shape in this pattern. So we can see something's happening here with the matchsticks. Maybe my diagram's not great, but most of you were able to draw the next shape yesterday. So I think we have these things at the end. And then instead of one box, I think we're going to have 3 boxes in this one, maybe. Does that make sense? Does that look like that'll be the next shape in that pattern? So we went from kind of no boxes to 1 box to 2 boxes to 3 boxes made with matchsticks, but still with the triangle at either end. Okay, we could draw the next shape in the pattern, but what we really want to find is a shortcut to counting the number of matchsticks, a formula that will get so we can count the number of matchsticks in any shape. For instance, the 99 shape. If this continues, what would the 99th shape look like? Because this is the first, second, third, fourth. So the formula for that sometimes is called the nth term. Nth for, instead of 4th, 5th, 6th, any number, n term. Okay, so what did we do? We created a table first of all. So the table would have the shape number and the matches or some, doesn't really matter what names you call each thing. So shape number 1, I think you found had 5 matches, didn't it? Shape number 2 had 8. If you just count them, you're literally counting them here. Correct me if I'm wrong here, but I think this was what our table, if you counted them up, you would get. So I'm literally counting the matches, 1, 2, 3, 4, 5, and put them in here for each shape number. And then you start to notice how many matches are additional each time. So there's an additional 3 matches each time. You can see that here. This number is going up 3 each time for every 1 extra shape. So that's something we call the rule. So the rule of this formula or this pattern is to add 3 matches, or just add 3. Okay. And then we started to think about, okay, if I want to get the 99th shape, I'm not just going to keep adding 3 forever and ever and ever. 99 times. We want to get a shortcut to get there, so we create this formula or nth term for this sequence. And we use this repeated addition of 3. So adding 3 a bunch of times, 1, 2, 3, would be multiplying, wouldn't it? So we now know that in a formula, we're going to have to multiply by 3 to get to the 99th one. So what do we multiply by 3? Well, to get the number of matches, we know we have to multiply the shape number by 3, at least. But there was a problem. Multiplying the shape number by 3 did not give the right answer, because if I multiply the second shape, 2 times 3, I get 6, and I want the answer to be 8. Yes. So we need to figure out what was kind of there at the start. What was the constant that's always there? There was an extra 2 matches. How did I figure that out? There's a few ways of doing it. You can kind of do it thinking 1 back, what was there originally. If I subtract a 3, I'll go back to what was there originally. And that would be there's 2 there originally. Or you can look at the shape and figure out, like we did with the bricks yesterday, what was always there at the start. So, or you can just think about what will work for the formula. 4 times 3 is 12, but I want 14, so I need an extra 2. 3 times 3 is 9, but I want the answer to be 11, so I need the extra 2. So that's where the extra 2 comes from. You can do it a few ways. But we didn't like to write it like this because that has words and not letters. We want to use letters in maths. So, Chloe? Yeah, 3s plus 2. So that's how we write it using maths language, which is letters. These letters are something called variables because they vary. The shape number will change depending on which one you're looking for. And the answer for the matches will change depending on which shape you're looking at. So they vary. They are called variables. Sometimes they're also called pronumerals. The letters can be called variables because they vary, or this pronumerals. Pro numerals, anyone figure what that might mean? Numeral, not sure.
Like Italian.
Yeah, so in Italian you call them Roman numerals, so they're for numbers, yeah? So numbers, pro, sometimes can mean instead. So instead of numbers, you can think about it like that. So instead of numbers, we put letters. So pro numerals is something in its place. So these letters sometimes are called this. So the x in algebra is a variable or a pro numeral. This number here that doesn't change, is always adding to, is something called a constant. Anyway, we just can now use this formula, that's our magic formula, to find what the 99th term was. Because the 99th shape, how many matchsticks are in that, I can now use that formula. M is equal to three S's. 3 times, we're looking at the 99th, so 3 times 99, and then add that to, so 3 times 99, we figured out yesterday, was 297, plus 2 is 200, so there'll be 299 matchsticks without having to draw it in the 99th shape. So that's what we did yesterday. Okay. We also looked at number patterns yesterday, just find the next term in the sequence and so on. That's what we're going to start with today.